So let's talk more about let's talk first with the issue that we're trying to fix on Planet Linguist, and then that will carry us through to how the solution of the problem and the solution to problems like it. So the issue is that we've got database and our cloud server. And then we have, in this case, 2 clients out here somewhere, right? Computers don't look like that anymore, but we'll pretend they do. And these guys are actually going to talk to each other. But they're going to do so through the cloud. And the issue is, first of all, I want to store the conversation. So in the case of Planet Linguist, I want to store the conversation so we can do stuff with the process of learning a language. So as we're writing messages back and forth, there are probably vocabulary words I want to remember, or phrases I'm getting taught, or whatever the case is. So I want to hang on to those, and just like Skype or anything else, they keep a history, right? So we're going to keep some history of messages. And so whenever this guy writes message 1, we go back and we write it into the database. Fine, easy enough. The issue is, when this guy writes message 1, right, we're used to IM stuff, so instant messaging, this guy should immediately receive the message. So there's a twofold issue. One is, let's assume we had it here in our server. Let's assume that we have it here, right? How do we push it to the client? So we could use WebSockets, but WebSockets still aren't fully implemented by all browsers or by previous versions or whatever. So we could and just say you're required to use some new browser. But the other option is long polling. So, but the problem here is, how do I get the server to communicate to machine 2 in my IM situation? Then the bigger problem is, so we know we have WebSockets and we could use long polling. The bigger issue is, from this, there's no way for MySQL or any other database to tell me there was a thing just inserted. So there's no way for me to have a listener that says, hey, let me know when someone writes to this table. You can construct them probably in MySQL or something, but basically what the code amounts to in MySQL is there a message? Is there a message? Is there a message? Right, so it's the dog method. Like, how about now, how about now, how about now? So we could do the same from the server. We can ask, is there a message here? We could do it once a second or whatever, but I'm still going to end up having no less than well, it could be less than, but on average I'm going to have a half-second latency plus whatever my latency is to send it up to the client from the time they send a message to the time you receive it. And when you're typing, you realize pretty quickly that a half-second is a really long time to wait for a message. And so the same thing happens if you're on a cell phone with a guy on a car behind you and you can read his lips and see when you receive the message from the cell phone. It takes a while to get to you. So the other issue is, if I poll today every second for this guy's message, I also have to poll every second for this guy's message. So I'm polling twice a second for one conversation. So now put 1,000 people on the site, and I'm just hammering this thing with polling. So how do we avoid the polling on MySQL? And the answer is, or any database, the answer is we don't. Because it's not designed for that. It's designed to store information, and then we can find out if that information was stored. So what we really want is not something like a MySQL trigger mechanism. What we really want is someone to notify us when that data goes in. And so that's where something like RabbitMQ comes in, because we're going to make a message queue. So what I'm going to do is, to solve this, I'm still going to write this message down into the database so that I have it stored there. The other thing that I'm going to do with it, and let's see, that's going to be my message queue. The other thing that I'm going to do with it is I'm going to write it into my message queue. And so the interesting questions are, is someone listening to this, right? Am I just using the message queue like a temporary database or something, and I just need to go check later if there's a message or something? That's one thing, fine. But then the next question is, if someone's actively listening to this, can I have more than one active listener? Like, what's the many-to-one relationship, right? And so what we have is, there's a mechanism called publish, subscribe, or for short, pub sub. And pub sub is basically a mechanism whereby you can have a publisher and one or more subscribers, or 0 or more subscribers, in fact, to that thing that's being published. So when in this case, let's draw this out a little bit differently. Let's make this our representation in here of client 1 and client 2. So here, client 1 writes something into the message queue. Client 2 has a listening relationship. With the message queue. So effectively, every time something is written to this message queue, the listener is notified about it. So like for example, in multi-threaded coding, like at the C level or something, or C++ code, right? It's pretty typical that I have multiple threads going on. And what I might have is this thread does something. Maybe this thread handles messages or something. It happens a lot for messages. So I have this thread, as I heard a prof from Stanford one time say, we could have many threads, but I have 2 hands, so we're going to model this with 2. So this thread runs through and handles a message, and then he sits and he waits for new messages, and he does nothing else. And this thread over here is like our normal operation of whatever's happening in the system, right? So he gets to a point where he wants to send a message. He notifies this thread that he has a message, because otherwise, again, this thread would have to sit there and poll, is there a message, is there a message, is there a message? So this one will have, like in P threads, you have like a condition, I don't think it's called notify, but whatever it's called, right? It's going to do a notify to this thread and tell them, hey, there's a thing, go check it out. So now this thread will go look at that shared resource that they have and go look for the new message or whatever, the new item in the queue or whatever. So a pub sub mechanism lets the same thing happen, but over a network, so that I don't have to have those things within a single process space, like shared threads where they have shared memory, or processes that are sharing memory or whatever. And so pub sub is going to happen over a network, but it's going to do effectively the same thing. So when client 1 writes this message into the message queue at that point will say, do I have any listeners? And if he does, then he'll tell the listener, hey, you got a message. And I don't know about the implementation particular of RabbitMQ, but you can kind of just reason out in your head, right? He either sends the message with the notification, or he just sends a notify, and client 2 comes down and says, my 2 looks an awful lot like a 1. Client 2 comes down and says, hey, give me the next message, or give me however many messages you happen to have queued up for me at this point. So same thing with this. There's a few different implementations we can have of this. We can have one where we hang on to messages as they come out, or we could have one where if there are any listeners now, then we notify them of the message, and once the message has been received, then we yank the message from our queue, right? So you can kind of imagine a few different iterations of this. Again, I don't mean this to be specific to RabbitMQ, and I have no idea which ones RabbitMQ supports or not, but you can have a situation where I say, okay, this queue has exactly one listener. If there is no listener, then queue messages up until a listener shows up. If there is a listener, then dispatch messages as soon as they come in over to our listener. I could have another one that says, I don't know if I will have listeners, so if there's a listener at the time, then dispatch the message to the listeners, and if not, then just throw the message away. So in this case, we could change this later, right, in the case of Planet Linguist, where perhaps a teacher has many students, and so we might actually have multiple listeners to this message. So the message gets sent, and all the subscribers get notified, which is fine, right? This message queue, however many listeners we want, can come in and say, hey, register me as a listener, notify me when this thing happens. So from client one, what happens when I write a message? I write it, I tell the server about it. Now the server is going to write it to the database. Then the server is also, on behalf of client one, going to have this message queue. Client one will have a message queue. So in this case, where we know we're talking back and forth, right, we're going to have a second message queue. Whatever. Contrary to popular belief, that's a 2. Okay. And again, they just reverse roles. So let's see. So this guy's going to write something into it. He'll get it back. And in this case, when he receives the message gets cleared out of the queue at that point. So the message queue that we want for this is one where all messages must be acknowledged. In our case, that means read. And that keeps us from disappearing messages. One other thing that we end up keeping here, again, some of this may or not be the actual functionality, but it's what should the functionality be, or what might the functionality be. The other thing here is C2 is also going to write a cursor, because on the web we're stateless, so anybody could disappear at any time. And so if I log back in, which messages did I receive before? And we're going to need that when we connect this mechanism too, I think. So anyway, RabbitMQ gives us this ability to do this message queue thing. Okay, so now on the client side, let's go back to that problem where we could use WebSockets. So that's one option. Let's go with the more difficult option, because WebSockets are probably a little bit easier to implement, but they don't work on all browsers, right? Some of the older browsers don't implement those. So I need to get a message push by the server to the client. Am I rehashing information if I talk about long polling? Do you guys? Okay. So the message on the web, right, always has to be initiated by the client, because we throw out WebSockets. Once we throw out WebSockets, then my statement becomes true. So the client is going to send a message to the server that says, it's a listen message in there's a word that escapes me, but his desire is to have a listen message, right? In reality, it's just an HTTP request that returns some data. But the HTTP request is, hey, is there anything in my message queue? And so what's going to happen here is, so the previous case where we had MySQL, right? What's going to happen? This listen is going to come down to the database. The database is going to say no. It's going to come back up to the server. The server is going to say no, and he's going to say listen. And so we're going to repeat that. So again, he could delay it every 1 second. We've got a delay, and now not only like before we talked about we're going to thrash our database, we're also going to thrash our server. We're going to just have network connections connecting and disconnecting all day long, saying, how about now? Do you have a message yet? Do you have a message yet? Okay, so let's not do that. So this listener, what we want him to do, a long poll, means he's going to ask, it's P-O-L-L, not P-O-L-E. So he's going to ask, do you have anything for me? This is where we have a couple of options. RabbitMQ, I think, has since implemented this. We had to implement it ourselves. But one option is non-blocking. So non-blocking is, do you have a message? Do you have a message? No, no, no. Blocking is our other option. And he says, do you have a message? And don't come back here until you've got one. And so then in that case, the server then would say, do you have a message? Do you have a message? Whatever. Once the server knows that he has a message, he's going to return it to listen. Okay, so that seems to work pretty well. So we've solved the issue on this side, right? That I'm going to block, I'm going to wait until you have a message. Once you have a message, so this listen packet, right? It's just HTTP. So he's going to send out some GET request that is, do I have a message? And what we're going to do in the server is just not give it an answer. So that function that gets called in, say, CodeIgniter or whatever it is just not going to do anything. Once we have a message, then that function will return data. So it'll return an HTTP request. So this ends up being an HTTP request that just gets hung. We send it to the server never replies until it gets a message. Okay, it all works great until we remember that TCP/IP has timeouts. So if I send this message to a server, and typically it's going to be 60 seconds or 30 seconds, and I don't hear anything back, it's the client, my web browser, is going to drop the connection on me. And at the JavaScript level, there's nothing I can do about that because it's happening at the TCP layer. So TCP is just going to come, it's going to, at the JavaScript layer, return back to me and say, you didn't get anything because you timed out, right? And then I'm going to scramble to say, hurry up and get another listener back in there. So instead, what I want is this third option, and all of these things that we implement on the web have been like existence in computer science for like 100 years. So this has been in C forever in the form of the select statement, which is blocking with a timeout. And so I send this listen in and I say listen for 15 seconds. And so it sends this in. If after 15 seconds I don't have a message, then I return back to the caller, well, you timed out. Just try again. And so the caller just waits. When he gets a return, he says, did I have a message or did I get a timeout? Oh, you got a timeout? Okay, reinitiate the call. And so then this thing only lasts, if we have some network delay, it lasts 17 or 18 seconds or something, right? If we're on courier pigeons or something, that's a different issue. But as long as our protocol's over sort of typical things, our delay times can get up to a few seconds as typical, right? Typical highs. So this will never hit our 30 seconds and we should be fine. We shouldn't be getting all these TCP errors and other issues that we don't want to have to deal with. So this is what RabbitMQ was missing in the previous version, is they had one that would block, but that's totally useless on the web because it's going to time out. And they had a non-blocking version, which again is not helpful because we want to sit around and wait for a message to actually be entered. We don't care in the meanwhile. So, okay, so I solved the web side. I solved the HTTP side. Now I've got this long pole listener that comes in, listens for 15 seconds, and then times out. But I would still have the poll here. So that's where the message queue comes in now. So now the listener comes in to kind of this RabbitMQ section of our code, and now he comes down to the other guy. He knows who he's listening to, so he comes over to this message queue and says, I'm listening here. I just came back. Is there anything in the queue for me? So this is the part where if he doesn't have a listener right now, this message queue needs to store and hold that message until it's released. Because I could have the case where I just sent a message back saying your listener timed out, And then client 1 says, oh, here's my IM, right? I still need to make sure I get that message. So when I come back in, this guy, this message queue, I need to have a message queue that retains my messages. Excuse me, it's like a mailbox. It retains my messages until I come collect them. But it's like a message, it's like a mailbox with a guy who pokes you if you happen to be there at the time. So now we have the ability for this to come in and say, give me a message or timeout at 15. We can come down to the message queue. If there's a message right there, it immediately returns the message up and returns it to the client, and the client puts in a listener again to say, listen for this next message. And then of course on the same side, this client, if someone types something in this IM, can send that message back to the server. Server will put it on the other message queue, and so on and so forth. It goes on. And of course, at the same time, we're sending one out to our database. But for this scenario, our database is a write-only device. We aren't reading anything out of it. We might read later if we say, this guy lost internet connection and he pops back on, or he had to log back in or something where he wasn't, his message queue is destroyed. He doesn't know about his message queue to go ask about it anymore or whatever. So we need to figure out what messages has he never seen before, and then send him those messages, which is fine to queue to pull the database, because I'm just asking once, what are all the messages I missed while I was away? I've logged into a new message queue, so I won't miss any new ones. Takes care of our race condition there. Spit out those and bring those back in. And this mechanism with the message queues is one of the implementations of it is a publish subscribe, where I could have, like we said, we could have multiple listeners, maybe a whole classroom listening on this thing, and it just makes sure that it keeps its own list of who's listening to me, and whenever it gets a message, it notifies everyone on the list. How's that?
Could you say again what the cursor is, or like specifically how is it stored at the server layer in memory, or how does it work?
Yeah, so here the cursor, basically every time I read, so this is for client 2 in this example, every time I read a message here, I'm going to write to the database and say this is the ID of the message I last received.
Okay.
And then if I get disconnected, whatever, and there's 100 new messages come in, when I connect back up, then my listener knows, goes to the database and says, with this cursor, tell me what messages were sent while I was away. Okay. And then we can send that 100 messages back to him, and then any new messages will show up in the queue. So it's basically because this message queue is going to be in memory. And we know that we can have things like a server restart, and clients can come and go because of the stateless nature. And so the cursor is just a way to keep track of where I was.